to go over how to calculate the percent composition by mass using gram formula masses. So the formula we're going to use is on the back of your Regents reference table. So in general, it's going to be the mass of the part, so the element or part that we're interested in, over the mass of the whole, which is usually the whole compound, times 100. And you have to make sure you actually show that times 100, or you're going to lose a point on your numerical setup. So the first one in your note packet asks you to find the percent composition by mass of oxygen and aluminum oxide, and it gives you the formula. If you were only given the name, you would have to write out the formula because you have to know what the subscripts are. So the first thing we're going to do is figure out the mass of the whole compound, so which is your GFM, your mass of 1 mole of it. So for the aluminum oxide, you have 2 aluminum, so we're just taking the values right off the reference table, plus your 3 oxygen, which will give us a mass of 101.96 grams in every mole of it. Now the element that we're interested in this question is oxygen, so we're going to find the mass of the part, which would be oxygen. So just 3 times 16. So then it's just a matter of just plugging those values in using the formula. So you would have your mass of oxygen, which is at 48, over the mass of the whole compound, times 100. So you get 47.1. You can usually round to like the tenths or hundredths in any of the questions unless it specifies. So then if we try out, find the percent of the by mass of nitrogen and aluminum nitrate, which has this formula. We just have to be extra careful with the parentheses and the 3 on the outside. So if we find the GFM of the aluminum nitrate, just keep in mind we have 3 nitrogen and then we have 9 oxygen here. So if we add that all together, you should get 213.01 grams. Then we're interested in just the part of nitrogen. So just remember you have to incorporate all the atoms of nitrogen in that. So with nitrogen, you would just have 3 times its mass off the periodic table, so that would give you the 42.03. So again, don't forget about that 3 because it's usually going to be the biggest mistake. Then it's just a matter of now they have the mass of the part, the nitrogen, and the whole compound. We can use the formula. So we're just plugging in the nitrogen that we're interested in, the mass of the whole compound, and when we multiply that by 100, and again, make sure you show that part, you're going to get 19.7 if you round off to the tenths. So on Edpuzzle, you're going to pause it here for a second and actually work this out in your note packet and then select the answer that you get at the end to check it. All right, and then one other type of compound that we can have to deal with is a hydrate. So a hydrate is where we have ions from an ionic compound that are attached or surrounded to 1 or more water molecules. They have a very specific ratio of water to the rest of the salt. So we're going to, in general, use the same formula that we've been using. The part is going to always be the water, and then the mass of the whole is going to be the entire hydrate. So this is an example of formula of a hydrate. So this would be sodium carbonate decahydrate. One big thing is that this is not a multiplication symbol. It's just the symbol for representing a hydrate to show how many water molecules attached. So we're not going to multiply anything between the sodium carbonate and the water. So this one wants you to find the GFM. What I usually tell students to do is know the mass of water or calculate that separately. So for the GFM of 1 water molecule will be 18.02, and I just got these values right off the reference table. I just find it's easier than breaking up the hydrogen and oxygen from each other. Students just tend to make less mistakes. So if we use the GFM of the whole hydrate, I should say, we're going to have the 2 sodium, my 1 carbon, my 3 oxygen, so that's the whole part of the sodium carbonate, plus my 10 waters. And again, I'm choosing not to break it down into hydrogens and oxygens there. So then it's just a matter of plugging in values from the reference table. So we have our 2 times our 22.99, and then we have our carbon, oxygen, and then here's that 10 waters, or 10 times 18.02. So if we add that all together, the sum gives us the GFM of the whole hydrate, which is 286.19 grams per mole. So you could be asked of how many, like what's the GFM of the hydrate, but we could also do percent composition, which is going to focus on the water. So what is the percent water by mass in the sodium carbonate decahydrate? So with this, we've already figured out the GFM of our hydrate. Just keep that in mind. We're going to use the percent composition formula, but we're going to do water over the hydrate times 100, so part over whole times 100. So with this, we have, again, the whole hydrate we already figured out, and then we have the 10 waters, so I'm going to fill that in as 10 times the 18.02, so all the waters, and then from there we can just calculate it, and then this rounding off to the tenths actually ends up rounding it up, so I got 63.0%. All right, so you should be able to use the percent composition by mass formula to figure out the percent composition of by mass of elements in different compounds or water when we're dealing with a hydrate.